was the curve is basically distribution of the temperature extremes for the previous time, right? Historical period. And this is the data set which is for the new climate conditions. Now you can clearly see that this is a one example of if the climate is likely to be changed, then how the extreme climatic events, how they is going to respond. For example, if you look at this particular figure in the new climate probability distribution function, here it data sets are very important. Very important. Time series data sets are very important because it gives you an idea about in the time how different properties are behaving with respect to different time intervals. For example, if you look at this particular graph, it tells you about there is a random fluctuation of the time series around the for different time intervals like that. So that is called a purely a random processes. However, if you look at this particular graph, this tells you about the processes
बोलूं? हेलो?
थोड़ा पीछे चलता है। नहीं नहीं, लाइव है सब।
हाँ, हेलो हेलो।
अब आएगा, इसने एडजस्ट किया ना, थोड़ा सा पीछे चलता है।
हेलो हेलो।
सर
हेलो हेलो।
लाइव आएगा, इसका नॉर्मली आ जाएगा।
हेलो हेलो।
ठीक।
इस चीज़ का ध्यान रखना सर। So we discussed about the time series data set. So let's back to the basics again. When you are talking about the climate extremes, what is the important thing is time series data set. What is time series data set? The data set which is we are collecting in different time interval. It could be your annual data, it could be your monthly data, it could be your daily data, like that. So basically when we are talking about the time series data set, it is a collection of the data which we have recorded in different time period, and we are representing that data for to know about their fluctuations. Okay, so the long term, when you are looking at this particular data set, we are looking at the long term mean, and this long term mean tells you about the long term behavior of your climate extremes or different types of climate variables, or if you talk about, let's say here, temperature, rainfall, etc., like that. And the fluctuation around these different types of long term mean is basically called the random fluctuation around the data set. In the mathematical formulation, we can basically represent this time series data set in terms of xt is equal to the long term mean, which is the deterministic component, and there is a stochastic component or random component of your time series data set. Now the time series data itself can be divided into multiple parts. I have shown here only the 4 types, but there are multiple types of the time series data set can be possible. The first one is purely stochastic. The second one is where we have a trend in the data with your basically the random fluctuation around that particular trend. The third one is basically we are talking about the periodic fluctuations with the random fluctuation around that particular data set. And the fourth one is basically the stochastic data plus jump. So jump is basically where we have the long term mean behavior has been shifted to some other level. It could be vice versa also. Here it is shown that the long term mean has been increased significantly, but it is also possible that the long term mean has been decreased significantly. It is basically suggesting that there is a abrupt behavior of the hydrological property in that particular region. There are something abrupt has been happened, and that has basically abruptly changed the hydrological behavior of that particular regions, like that. When you are dealing with the time series data set, here we are basically looking at the different types of realization of the data set. Let's suppose you have collected the data from 1901 to 2025. You can divide your data into, let's say, 1901 to 1925, 1926 to 1950, 1951 to 1975, 1976, and so on. So this is called a realization of the data set. Why we do this? Let's suppose somebody will tell you about, okay, there are significant change in the climate properties in one particular region. How do we prove this? Then when we have to when we divide our data into different realization, we can compare what happened to the long term mean, what happened to the fluctuation around the mean, and what happened to that particular, if there is any jump or any kind of a deterministic fluctuations around that particular time series data set. So that is what it is important, where we look at different realizations and then we can compare with all of these different realizations, and then we try to understand that from which part or from which time period we have observed there is a significant change in the time series data set in different realization terminologies like that. The another term important aspect of collecting the time series data set is forecasting or projections of the future. Why we do that? Basically, let's say we have a length of the historical record, since let's say here we are collecting the rainfall or discharge data from 1951 till 2025, and let's say we are using this data for a particular project. So here the economic life of the project is more than the data collected record, and therefore we need to do some sort of projections of the data set so that we can match towards the end of this project what would be our hydrological behavior or climate extreme behavior like that. So therefore the future projection is, that is why it is very important, because we are trying to look at how this project is going to be affected by long term fluctuation of your climate change or any particular hydrological variable in the future terms, and then we can basically change our operations or different types of project operations accordingly. So this is basically a kind of a flow data. Let's assume we are measuring a flow in a one particular locations for different time period, and then we are basically, this is a random fluctuation and this is the mean flow. We can basically look at this particular historical behavior and you can try to predict for the future terms as well. How do we do that? Let's say we have 1970 to 2010 data set and we are trying to extend our data for 2040. So this is basically the known part, and then this is basically the forecasted or unknown part. How do we do that? Basically we divide our data into two parts, calibration and test data, and then we try to look at some forecast error, and then basically we calculate some sort of mathematical formulation, and then we basically try to calculate the error associated with the forecast and projections. So this is basically the climate change, how the climate change are likely to be affect extremes by looking at the, let's say, time series data set, how we are going to tell about whether the extreme has been changed or not, what kind of the procedures. So far we have already discussed like that. Now the next part of the time series data set is called frequency analysis. Frequency analysis is basically we are trying to look at particular data set about their probability of occurrences. What is the probability of occurrences? So if you toss the coin, let's say, what is the probability of occurrence of head? 1 by 2, 0.5, right? And what is the occurrences of tail? Is 1 by 2. So let's say you replace the coin with dice, and if what is the occurrences of, let's say, 6 is 1 by 6, right? So similarly, the probability of occurrences means what is the chance of occurrences of one particular event. Now you just extrapolate this concept to the extreme climatic conditions. How we can calculate the probability of occurrences of extreme events in terms of their magnitudes? Can we calculate the magnitude of 100-year frequency flood? 100-year frequency flood means the flood event which occur once in 100 years time period. What is the magnitude of that particular flood? So here basically comes the frequency analysis, where we basically look at the hydrological problem and we basically characterize by their occurrences of the extreme events like that. For example, we talk about extreme events, extreme floods, extreme precipitation events and low flows also. So particularly when we are talking about the frequency analysis, we are interested in extreme values either in high direction or either low extreme direction, and then what is the magnitude of extreme events which are proportional to the frequency and occurrences. So for example, if you look at this particular figure, it tells you about that this is the parent distribution. Let's say you are recording the rainfall or discharge or temperature data at one particular point. You have collected the data set. There are two different extremes in the data. One is we call high extreme end, the another is called low extreme end. High extreme end, where if you look at this, where the x values are very high, the probability of occurrences are very low, right? So this is a kind of a extreme events we can classify. Another way, if you look at here, the low magnitude direction, here this is the very low kind of the data set, and the probability of occurrences are very low also. So that is called the low extreme flows. When you are talking about high extreme flows, for example, you are talking about extreme precipitation events. Extreme precipitation events means when the magnitudes are very high and the frequency of occurrences of that particular magnitude is very low. Low extreme flows are basically, let's say you are talking about drought events, or basically you are talking about some sort of very low flows events in a particular river basins, where the occurrences of that particular extreme events are very low, like that. So how do we handle this frequency analysis using some sort of distribution functions? So basically, how do we do that, this frequency analysis? We have to apply some sort of distribution functions, density functions, and we have to calculate the probability which are associated with different magnitude. So this is the one example of the you aware about histogram? What is exactly histogram? So what is histogram? Distribution of the data set. Okay. So you are dividing the data into different parts. For example, let's say your data set is varying from 0 to 100. You are saying that, okay, I am taking the data 10 bin size, 0 to 10, 11 to 20, 21 to 30, and so on, right? This bin size you are dividing the data, and based on this division you are calculating how much values are present in different bins. How many values are present in 0 to 10, the total number, and there 11 to 20, the total number, and 21 to 30, and so on. Once you have this total number values for different bins, you can make this kind of the graph, which is called histogram. Histogram is basically you are trying to estimate the frequencies of points with respect to different bin size, and you are plotting this data set in a particular graph style. That is basically called the histogram. Now imagine if you are considering this bin size 0 to 10, but you are consider, let's say, this bin size so small, is very small, that is, then it will become like a probability density function, where the bin size is very, very smaller. And there is another difference between the histogram is, histogram directly gives you the probability, okay, because let's say you have one bin size where you have values around, let's say 20, and there are total number of values is 100. So what is the probability of occurrence? 20 by 100, right? That is 0.5 or something like that. So but that is your probabilities, but when you are talking about the probability density functions, it basically tells you about the probability densities rather than your probability values. So when you are applying this probability density function for frequency analysis, there are certain conditions we have to always remember. The probability values are always equal to 1. It cannot be more than 1, right? So if you just add a coin, tossing of coin, there are two conditions are possible. One is your occurrences of head, one is occurrences of tail. 1 by 2, 1 by 2, if you add, that is equal to 1. Similarly, if you do the similar exercise for your hydrological data series or climatological data series, you are calculating the probability of different extreme events. If you add all these values, it will always gives you 1. So that is the first condition of the any functions to be a probability density functions. Then there is another condition is whenever you are using the probability density functions, it has to be greater than 0, which means probability cannot be negative number. It is always a positive number. So this is basically the two conditions are very important when we are choosing any kind of the probability density functions for your flood frequency analysis. So there is a two forms of the probability density function. One is called the PDF and another is called the CDF, the cumulative density function. The probability density functions are basically that directly gives you only the probability density values. Cumulative density functions are basically those, cumulative distribution functions are those which directly gives you the probability values of different extreme events. So it is always, you can see that this curve is always a kind of a S curve, right? So here the minimum value is 0 and maximum value is 1. When you are approaching towards 1, there are the region where we have lots of extreme events. And here also when we are approaching here where the probability is very low and there is a low values, that is also we call the extreme events. That is how basically we differentiate between the PDF and CDF like that. Now we are collecting the extreme events. How do we define the extreme events? So as we just we discussed about all the data set we are collecting in the time series format. Okay. So time series format means we have a time window and for each time window we are collecting the data points and we are plotting the data points in terms of time series graph. If you look at this data here, you can see that there are lots of values which are crossing above certain thresholds. Okay. So basically there are two ways where we can define the hydroclimatic or hydrological extremes. One is called the block maxima approach. You can write down this block maxima approach. What is block maxima approach? So you consider a block of the data set. Let's say you are using 1 to 365 values. Suppose you are measuring rainfall, flow, temperature or any particular hydrological variable, and that is basically you are measuring daily level, daily scale. Okay. So for each year you have 365 values or 366 values. Okay. Let's imagine we have only 365 days. Fix the 365 days number. So the block size would be 365 days. 365 दिन का एक block size बन जाएगा. For each block size we are referring that what would be the maximum value for that particular block. It could be 365, it could be 100, it could be 200. It depends upon you what kind of the block size you are using for that particular extreme events, identification of the extreme events. So the most general way is basically yearly block size when we are considering what is the total maximum value for one particular year. Okay, that is called the block maxima approach, where we are highlighting for each different blocks what is the total number of maximum values. So this is particularly called the block maxima, and this is basically called threshold based method, which is called peak over threshold method. Peak over threshold method is basically we are using some sort of threshold values, and based on that, if the values are crossing above that, we can consider as a extreme events. So this is the two ways you can basically differentiate, or you can basically extract the extreme events information from your time series data set. Now you will be able to extract the time series from your, if I give you the data. How I define the? Yes, threshold is basically a very subjective thing. Let's suppose it can depend upon region to region as well. For example, you are talking about urban areas where 100 mm or more than that rainfall can be considered as very hazardous. So in that particular region, 100 mm can be a threshold. That is basically, yeah, minimum rainfall amount is 2 mm. That is for the lower minima. Dry day and wet day. But we are not specifically focusing on the dry and wet. We are focusing on the extreme events. Okay. So extreme events can be classified as a predefined value threshold, or it is possible that you can think about a selection of that methodology where getting the extreme events which are not dependent with each other. इसका मतलब ये होता है, let's suppose today yesterday we have received a very significant amount of rainfall, and today we also receiving a very significant amount of rainfall. It might possible that these two events are related to each other. How? Because these two events are evolving from the same synoptic system, same climatic fluctuations. Okay, so that is why it is possible that these two events are dependent. I will tell you another example. Let's suppose you have a river where you are measuring river discharge, and at certain point, let's say during the monsoon, you observed a very significant amount of flow, है ना? In the next day you are also observing very high amount of flow. It is possible ना कि एक दिन अगर बहुत ज़्यादा flow आता है तो of course अगले दिन एकदम zero नहीं हो जाएगा. It will have very high amount of flow as well. But it is possible that the first flow might you can consider as extreme events, but the second flow is actually dependent upon the first day flow. Why? Because it might possible that the first day flow has been already saturated the grounds, and therefore even the smaller amount of rainfall can create more significant amount of discharge. So therefore these two events are sort of dependent events, and when these are dependent events you can consider only single events, because dependent events if you are consider you are violating the rules of the probability density functions, this extreme value theory. So therefore we consider the threshold in such a way that these events whatever we are getting should not be interdependent, it should be it should be independent in the nature, like that. Or sometimes of threshold we select based on some sort of ground level informations, like that. So क्या चीज बेस वैल्यू वही तो हम समझा रहे हैं ना. बेस वैल्यू इज हियर इज 60,000 क्यूमेक्स वी आर यूजिंग, राइट. It is based on some subjective knowledge. Okay, here I am just giving you one example. It can be 60,000, it can be 80,000 as well. It depends upon site to site. Let's say there is a bankful condition. River की bankful condition होती है ना कि हर जगह capacity अलग अलग होती है. We cannot compare Ganga in the upstream and Ganga in the downstream conditions, right? So the water level or bankful conditions will be different. So therefore your values will also be different, like that. So it's a site specific. It is also based on your dependence and independence criteria as well. कि अगर हम एक threshold बना रहे हैं ना, अगर let's say you draw the threshold here as well, there are multiple events you will also classify if you lower down this threshold. तो उस केस में ये होगा कि you will have multiple extreme values which are dependent to each other. और जो dependent to each other होगा, then what will happen? You will have some sort of violating the extreme value theory that we will discuss about the next slides. What is that? So now you are able to understand that you will be able to extract the block maxima based approach, the peak values, or the peak over threshold based approach to identify the extreme events. है ना? These extreme events can be either you can use as a single variable or bivariate or trivariate and etc. If you are using single variable, it's a single climatic extreme. If you are using two variables together, it could be your compound extremes. So now you have, let's say, multiple extreme events you have classified. You can make the probability distribution functions of this, and this is, let's say, the parental distribution of the data, and the extreme edge of the data set is considered as your the probability occurrences of the extreme events, like that. So similarly, what we have just explained in the previous slide. So if you look at the probability of occurrences, here you can mark these probabilities, and here you can see that the probability of occurrences of different extreme events, like that. So when you are talking about the extreme events, extreme values, extreme values generally do not model based on the regular probability density functions. That requires a special case of extreme value distributions. So these are called extreme value distributions. There are three types. One is called Gumbel distributions, second is called Frechet distributions, and third is called the Weibull distributions. These distributions, this is the shape of the distributions, how you can look at how it basically behaves. When you are talking about, so these distributions are function of generally three variables. When your eta value is equal to 0, this will become your Gumbel distribution. When your eta is greater than 0, that is called the Frechet distribution. When eta is less than 0, that is called the Weibull distribution. Okay. So this is how basically we demarcate these different types of distribution functions. So if you look at this Weibull, Frechet and Gumbel distributions, it is basically looks like this function. Almost similar, but if you look at Frechet, for example, it shows that this is the high heavy tail distributions like that, where the probability of occurrences of extreme events or extreme events are basically very high probability of occurrences in particularly Frechet distributions like that. So this is another experiment here. You can also do if you know the R MATLAB or any particular programming language. So here basically you can take the normal distributions data set. You can extract this extreme values based on block maximum approach, and you can make some sort of distributions. This distribution will always comes as a Gumbel distribution. If you take the values from the exponential distribution function, and if you just extract the maximum value each time, you will get some sort of again a Gumbel distribution. But let's say if your parent distributions are basically a uniform distribution and you are extracting the extreme values, that will basically consider will behave like a Weibull distribution. So this is some sort of experiment you can perform. Basically you consider one variable as a normal or Weibull or normal or some different types of exponential or uniform distributions, and take out that extreme values from these distributions, and based on that you would be able to calculate what is the extreme value distribution behavior based on this data set. So when you are talking about these distribution functions, we generally treat the extreme values based on some sort of extreme value theories. Extreme value theory or extreme value distributions are primarily the Gumbel distributions, Frechet distributions and Weibull distributions. Okay. There is another generalized form of this distribution is called generalized extreme value distributions. So where all these three forms are, we club it together, all these three forms, Frechet, Gumbel and Weibull together, and then basically make some sort of generalized extreme value distributions where we can classify this is type 1, type 2, type, and this is type 3 based on their different functions like that. So this is all about how we are dealing with the extreme events. If you have any questions, you can ask. Generalized distribution क्या है? हाँ. So basically, so suppose let's say you have collected the extreme value. ठीक है? अब एक्सट्रीम वैल्यू डिस्ट्रीब्यूशन जो एक्सट्रीम वैल्यू थ्योरी कहती है उसमें तीन तरीके के डिस्ट्रीब्यूशन होते हैं. गंबल होता है, फ्रेचेट होता है और वेबल होता है. ठीक है. अब एक एक करके सबको हम फिट करेंगे तीन को. दैट इज़ वन अप्रोच. देयर इज अनदर अप्रोच कि अगर हम इन तीनों का एक जनरलाइज फॉर्म बना लें और उसको एक साथ उसमें हम फिट कर दें और वो उसी हिसाब से ट्रांसफॉर्म हो जाए जिस हिसाब से डेटा है. सो दैट इज़ कॉल्ड जनरलाइज एक्सट्रीम वैल्यू डिस्ट्रीब्यूशन. वो अपने आप उस टाइप को असाइन कर देगा जिस टाइप को आपका डेटा है. दिस इज हाउ बेसिकली वी कैन मॉडल द डेटा बेस्ड ऑन देयर डिफरेंट टाइप्स, एंड दैट वी विल बी एबल टू गेट द ओवरऑल पिक्चर ऑफ द डिस्ट्रीब्यूशंस. फॉर एग्जांपल हम डिस्ट्रीब्यूशंस क्यों निकालते हैं, हम किसी डेटा को डिस्ट्रीब्यूशन में फिट क्यों करते हैं? एनीवन कैन आंसर? व्हाई वी फिट द डेटा इन एनी डिस्ट्रीब्यूशंस? अब हाँ एक्सट्रीम वैल्यू लाने के लिए तो ठीक है. व्हाट इज द, चलो भूल, हम एक्सट्रीम वैल्यू को भूल, फ्रीक्वेंसी ऑफ द डेटा सेट, एक्सट्रीम को भूल जाओ. अभी कोई भी डेटा हो सकता है ना. अगर हमने रेनफॉल कहीं मेजर किया है तो उसको भी तो प्रोबेबिलिटी डेंसिटी फंक्शंस में फिट कर सकते हैं ना. तो वो हम क्यों कर रहे हैं? वो हम इसलिए कर रहे हैं क्योंकि हमें पता चलना चाहिए कि जो 10 mm की रेनफॉल है या 20 mm की रेनफॉल या 50 mm की रेनफॉल है, उसकी प्रोबेबिलिटी ऑफ अकरेंस क्या है. क्योंकि अगर हम प्रोबेबिलिटी डेंसिटी फंक्शंस में फिट नहीं करेंगे तब तक हमें पता ही नहीं चल पाएगा ना. अब ये कोई सिक्का तो है नहीं कि हमें पता है कि भाई हेड आएगा तो 1/1.2 होगा. अब 10 mm का कितनी प्रोबेबिलिटी होगी हमें नहीं पता. इट इज़ ऑल्सो पॉसिबल दैट इन सम रीजन 10 mm, 20 mm, 50 mm probability is completely different from other regions. Let's take example of, let's say, Masin Ram and some region in Rajasthan. It's completely different distributions. So sometimes we fit the data in these, fit the distribution in the data set, and then we try to find out what is the statistical, behavior of these two regions like that. इन रीजन में, किस रीजन में एक्सट्रीम रेनफॉल या एक्सट्रीम फ्लड या एक्सट्रीम ड्राउट आने की संभावना कहाँ पे ज़्यादा है, लाइक दैट. ओके, सो दैट इज़ व्हाई वी बेसिकली फिट द डिस्ट्रीब्यूशन इन योर पेरेंट डेटा सेट, एंड सिमिलरली वी फिट द डेटा सेट फॉर योर एक्सट्रीम वैल्यू functions or extreme value data set for using some sort of extreme value distributions. हाँ, fit the data. हाँ, yes. And then once this data set is fit, basically this distribution functions are fit, we basically calculate what is the probability of occurrences of different events. Let's understand differently. Let's say we have the rainfall data for Indore, Bhopal or Lucknow or Delhi, like that. We fit the extreme value distribution for all these different cities, and then we will compare what is the probability of a particular event which is crossing above, let's say in one day 100 mm. एक दिन में 100 mm बारिश होने की संभावना किस शहर में सबसे ज़्यादा है. इस बात को कैलकुलेट करने के लिए हम इन फंक्शंस का इस्तेमाल करते हैं और उसके बाद हम उनकी प्रोबेबिलिटी कैलकुलेट करते हैं. तो उससे हमें पता चल जाता है कि उसकी प्रोबेबिलिटी कहाँ पर कम है या कहाँ पर ज़्यादा है. इससे हमें पता चल जाता है. हाँ, so it is possible that in one extremes, in one region, the lower magnitude is the extremes for that particular region. In the other regions might have a very high amount of extremes that can be considered as extreme conditions there. और इसको अलग तरीके से भी हम देख सकते हैं. Let's suppose in one city, let's say storm water management systems are not very efficient, so that the low amount of rainfall can also trigger the urban flooding there. That is why we have to upscale our system there so that we can manage it properly. That is the ground application of these kind of the theory or applications like that. Now this is all about extreme events, time series analysis of extreme events, how we do some sort of frequency analysis of extreme events. Now what is exactly compound extremes? Compounding क्या होता है? What is compound interest? Have you heard about compound interest? Simple interest, compound interest? हाँ? चक्रवृद्धि ब्याज हिंदी में बोलते हैं. हाँ. इंटरेस्ट पे इंटरेस्ट लग रहा है तो वो बढ़ता जाता है, एकदम कंपाउंड हो रहा है. कंपाउंडिंग. So compounding is basically, when you are talking about compound extremes, it is actually we are taking similar meaning from the compounding interest, where there is a one extreme, there is another extremes. When we are merging it together, it will amplify the effect of both the individual extremes. अगर वो दोनों एक साथ हो जाती है ना तो उसका इफेक्ट बहुत ज़्यादा टाइम्स एम्पलीफाई हो जाएगा. So that is what exactly the compound extremes meaning is. So for example, if you're talking about only drought conditions, it might have certain amount of losses we can see, but let's say the drought conditions are also coming with the hot extremes, heat waves. It might affect more drastically to that particular region, or maybe socioeconomic things we can see that would be changed there. So that is what we call the compound extremes conditions there. So we can see this example, and we can basically we will be able to understand what is exactly compound extremes. So let's say this is total precipitation amount we are measuring in a certain region. Okay, and then you are also measuring the temperature of that particular region as well from, let's say, 1965 to 2020, and 1965 to 2020, that is temperature. Now you are calculating different thresholds. Okay, so for example, you are saying there is a moderate values, there are severe values, and there are exceptional values. यहाँ पर वो clear नहीं हो रहा है, these lines are not visible because of some problem with projection. So there are some values, for example the temperature here. So when you are talking about the exceptional event, there are few data points were exceeding that particular threshold. Okay, there are severe events, there are few data points which are exceeding that threshold, and there is a moderate, lots of data sets which are crossing above that particular threshold. Similarly for the total precipitation as well, where for the exceptional condition there are few events which are crossing above that particular threshold. So when you are matching, when in that particular historical period when we have a very high total precipitation amount, or total precipitation amount is exceptionally low, for example here, and we have very extreme the temperature conditions. When you club it together, these two conditions, you will be able to find out there is a one event here, one event here, one event here, which is basically considered as a moderate. There is another event here which is called 1980s, where both the events were severe, and there is a one event here in after 2000 which we have observed that both the events were exceptional. You got my point? अभी निकाल लोगे कैसे होगा compound extremes? How do you find it? So basically, let's say you have temperature data, you have rainfall data, you have marked the threshold. So that is, let's say, exceptional threshold, above which you are measuring certain values, and then you are also measuring when this particular precipitation was so low below this particular exceptional threshold, and then you are matching both the events which are happening at the same time. Now you can observe that in 2000, after 2000, there is a one event where both the events were exceptionally high in nature, exceptionally high in terms of temperature or exceptionally low in terms of precipitation. तो ये some sort of क्या condition बनती है, इसे कहते हैं compound, dry and hot extremes. It has to occur for this condition. It has to occur in the same month or same day, same year or same day or same month, whatever the time series data we are considering, है ना, exactly on the same day or exactly on the same month. But it might also be possible, you can think about compound extreme as a cascading events. It is also possible that there is a drought event, and subsequently after one day or after 1 month you have heat waves, or vice versa, like that. Cascading compounding, cascading. Compounding is basically we are referring to the events which are happening at the same time, but it is might be also possible there is a lagged effect, है ना. lead and t minus 1 and t plus 1, something like that, lag events like that. So this is how basically you can calculate the compound dry and hot extremes from the data set. Okay. Once you identify which is the exceptional event or severe event or moderate event, you can mark those event, and then basically you can basically count those numbers, and then you can think, okay, so for example here you can see that after 2005 there is a many compound extremes we are observing, which means after 2005 there is a significant rise of the number of compound extremes in this particular regions like that. We will also talk about the Bhopal case study, and there I will show you that how frequent these compound extremes have been coming in that particular region. Now when you are talking about these different events, once you have classified these events, you can also calculate the severity level of the compound extremes. Severity level means it will tell you about what is the level of the severity of these extremes. If both the events are severe, for example here we have classified based on some sort of theoretical definition, severe, moderate and exceptional, like that. It can be also be quantified. कोई जरूरी नहीं है 3 classes में ही होगा. It could be multiple classes as well, right? So therefore we can derive a number or value which is called some sort of SCI index or severity index, like that. And this severity index will further classify your extreme events or compound extremes based on different classes. Now you can make these severity classes from, for example, 0 to -1 is your mild, -1 to -1.5 is moderate, -1.5 to -2 is your, let's say, severe, or -2 to below let's say -3, like that, is called your extreme compound extremes. So this is basically how you can calculate the frequency of occurrences of the compound extremes as well as their severity based on your compound or data set. So how do we calculate the severity? It is basically the function of the joint probability density functions. When we will do that exercise, so I will demonstrate how do we calculate this joint probability out of 2 different variables. SCEI is kind of a severity index. Okay, so it's a sort of severity index which is basically defining the severity of your compound extremes. Now this is example of Bhopal. This is a Bhopal districts in Madhya Pradesh. Here what we have done, we have used some sort of climatic data set, historical data and some future projections. I will only talk about the historical part. So historical analysis, what the data set we have collected, precipitation and temperature, and the future we have collected the data from +2 degree and +4 degree, like that. And for historical conditions we have calculated standardized precipitation index, standardized temperature index, and then based on that particular index we have defined the threshold, and based on that we have calculated the occurrences, and then basically the severity. Then basically we club it together and find out what is the overall interpretation of these results. This is one of the example of the compound extremes of temperature and rainfall for the Bhopal districts. Now you can see that what is this actually. So for example, this is the P30 and T70 value for the Bhopal. So basically here you can see that what is P30? You know percentile, 30th percentile, 50th percentile, 70th percentile, like that. Suppose you have data set, you can calculate the percentile values for that particular data. So that is similarly you can calculate the 30th percentile for the rainfall and 70th percentile for the temperature. Okay. So 70th percentile serve as a threshold for temperature, and 30th percentile is served as a threshold for your precipitation. Okay. So whenever temperature goes above the 70th percentile, that is a kind of an extreme event in terms of temperature, and whenever the precipitation goes below the 30th percentile of the precipitation, that is an extreme event for the precipitation. Now whenever these two events are happening at the same time, that is called compound extremes. And whenever happen in the monthly time scale, we have mapped it for entire for the Bhopal region from 1958 to 2022, I think. So this is how it no, it is actually dry. Yeah, so 70 percentile above, that is hot extreme. Extreme temperature, that is dry condition, drought, drought and hot extremes. So that is basically drought and hot extremes we are considering, and where we are calculating all these different values. So if you look at here, it tells you about after 2000 we are seeing more frequent occurrence of these compound extremes in the Bhopal districts. That is what we are observing from our data analysis. Before that, there are some occurrences there, but not that frequent one which we are observing like that. Now you can see that since let's say here 1999 or something like that to 2010, we have very frequent occurrences. Even every 3 months, every 4 months, we have this kind of compound extreme conditions. Yeah. Yeah, you can do P20 and T80 also. Yeah. When we are yes, there is not any specific rule as such, but you can take whatever the literature in this particular field suggesting that as you are moving towards more extreme conditions, for example, if I take here P90 and P10, that is more extreme. In that condition, you will have very few occurrences of compound extremes. So as you are moving towards the more extreme condition, that is the extreme level. And then there is a moderate, there is a severe, then very high, then severe and moderate. Like, so it is somehow. So if you are enhancing your threshold moving forward, you will have lesser number of compound extremes. If you are looking at, let's say, Indian scale, 1 degree is good for India. But if you are using for the data for the Bhopal and all the districts, here we have not used IMD. It's a different data set, Terra Climate. This is? This is reanalysis data set. Yeah, but it is also they are taking some information from the gridded data or station data also. Terra Climate. Terra Climate. So Terra Climate has data is 4 kilometer. 4 kilometer grid. So that is why. For this Bhopal, we are able to get the data for Terra Climate, multiple grids. So basically this. What is occurrence means? मतलब उस दिन हुआ है. That is one. One means that event occurred. So this is the monthly data. This is a monthly data. In which month we have seen this condition is true. We are plotting 1. If it is false, that is 0. What is the false condition? Let's say both the events not occurred. That is false. Yeah, either of them were occurred. Either of them was occurred, that is basically a false condition, because for the compound extreme we need to have both the conditions should be satisfied. Then it is 1. So that is how basically we have tried to IMD has 25 kilometer resolution. IMD has 0.25 degree. If you 0.25 degree means 25 kilometer. So that is a very coarse chips. So that is fine resolution data, but we were looking at only monthly scale, so I think this is the best one we found. And there are some literatures were also published which are giving you the best data set. You can use many data, but think whenever using selecting the data set, you should make sure that there is evidence that that data is useful for your study. So this is basically we are able to find out the pattern, and based on that we have classified, we have marked those events which has happened in the Bhopal. That is a kind of a compound extremes. And based on this methodology, first you have to basically identify the extreme conditions. Then you have to basically calculate the 30th to 70th percentile like that. And then you have to basically do some sort of true and false analysis, 0 and 1. If both the conditions are satisfied, that is 1. And based on that you can count the numbers. Now you can do multiple analysis from here. You can calculate what is the total number of occurrences between different decadal wise, or let's say you can also calculate what is their inter-arrival periods, है ना, कितने month का gap आता है, what is the average inter-arrival period for every 10 decades. Here we can also fit. When you are talking about 0 and 1, then you are talking about primarily Poisson or some other kind of the distributions which are dealing only the true and false. So that's a very specific type of distributions we have. So here basically you can classify these compound extremes, and then based on that you can tell about the pattern, and then you can also correlate with this pattern with your large scale phenomena, for example INSO or La Nina, or some sort of local phenomena, deforestation or extreme climatic events like that. So this is how basically you can correlate these compound extremes with different phenomena. Which slide? 10. So for example, let's say you are so in the hydrological field, or generally we consider 30 years is a good record. 30 years is a good record, है ना? So therefore, if you divide our data into 30 years time period, that is tell you some sort of long term processes, है ना? If you take only 5 years, it is a short term fluctuations, but when you are taking the 30 years, it is sort of long term fluctuations. So if there is a significant change in your processes, so 30-year record will tell that information more clearly. Suppose 1901 to 1930, there was very minimal effect of absence effect of this anthropogenic activity and all, purely natural system. 1931 to 1960 same. Then 1961 to 1990, there is significant rise of the land use, land cover conversion and industrialization like that. So when you divide your data into 30 years realization, you will yeah, you can do that. That can be also be, but 10 years difference might not get you very soon. Yeah, that we can also test. We can also test whether there is a significant change in the data set or not. So the major point is here is that when you divide your data into different realizations, you try to look at the distributions of the data or statistical property of the data, whether it has been changed or not. Sometimes it is we observe that there is a change in the mean behavior, but the standard deviation is remain same. Sometimes we observe that there is a mean behavior is same, variability has been increased. Okay, the standard. Good amount of, yeah. Any more questions? So you got the whatever I delivered, the compound extremes, everything. If I give you data, you will be able to calculate. 3072 देखो, इसका कोई गाइडलाइन नहीं है, ठीक है. हम कंपाउंड एक्सट्रीम्स में जो काम कर रहे हैं ना, अब कोई कहेगा कि हम इसको 25 और 75 भी कर सकते हैं, ऑफ कोर्स कर सकता है. हियर वी आर नॉट क्वांटिफाइंग द एब्सोल्यूट नंबर, वी आर सेइंग दैट दिस अमाउंट ऑफ एक्सट्रीम्स हैज़ बीन इंक्रीज और डिक्रीज्ड, है ना. अगर हम इसको दूसरे टर्म्स में बात करें तो लेट्स से वी आर यूजिंग सम सॉर्ट ऑफ 15 और 20 डिस्ट्रिक्ट्स एंड वी आर ट्राइंग टू फाइंड आउट विच डिस्ट्रिक्ट्स आर मोर वल्नरेबल या हम वल्नरेबिलिटी इंडेक्स जो निकाल रहे हैं या सीवियरिटी इंडेक्स, इट्स अ रिलेटिव टर्म, राइट. सो व्हेन यू आर यूजिंग 10 और 90 और 20 80, इट डिपेंड्स कि हाउ फ्रीक्वेंट इवेंट्स यू वांट टू कंसीडर इन योर डेटा सेट. If you are using 30 and 70, you will have more events. So that is basically defined by the threshold, which basically tell you about that event is flood. That should be. So here it's a very simple. So P30 is your threshold. When you're talking about the flood, it is that threshold where above that value will cross and become flood. It could be your danger level, या flood level, it could be like that. It depends upon site to site, HFL or danger level, like that. सबसे सिंपलिस्टिक अप्रोच यही है. कर सकते हैं. लेट्स सपोज हमने इमेजिन किया कि अगर हमारा जो रेनफॉल है वो क्यूमुलेटिव 10 mm से कम है. That is the absolute value, right? And we are saying that at the same time the temperature extreme goes beyond 45 degree. That is a one threshold. It depends. अब हम चूरू की बात करेंगे राजस्थान में तो 45 डिग्री जाना वहाँ पर कॉमन है, ठीक है. अभी मैं भोपाल की बात करूँगा या लेट्स से हम ऐसे एरिया की बात करेंगे जहाँ पर 40 डिग्री इज एक्सट्रीम कंडीशन. तो it depends upon your region to region, which region you are applying this algorithm. In some sense you can generalize, but yes, if you are using different regions, of course there will be consideration of the threshold selections. इसका इसमें लैग हमने नहीं लिया ना. इसमें हमने केवल इवेंट्स ये कैलकुलेट किया है कि जो एक साथ आए, देयर इज नो लैग. P70 and P30 which is occurring at the same time, that we are considering as a compounding streams. हाँ, in the same month. T-1 T+1 को हमने नहीं कंसिडर किया, but that can be also be considered this is a cascading effect. Any more questions? Okay, thank you. मैं तो यही घड़ी लगा के मैंने इसको
क्योंकि
मैं इससे जो है आवाज़ चली जाएगी बस। हाँ, इसमें क्या है, वॉइस ना वो इंटरफेयर करने लगता है बीच बीच में।
बहुत दूर लगता है।
हाँ।
तो आपकी थोड़ी बहुत आवाज़ लेगा तो ये अच्छा है।
हाँ, so I have shared one data set with you all in the Google that is WhatsApp group. Okay, so you can download that data. First we will try to look at the the mathematics behind. Then after that we will try to do some sort of hands-on exercise using Excel. Excel you all have, na? Okay, we will use Excel to calculate the probabilities from the data set. First we will discuss about what is exactly flood frequency analysis. So what is frequency analysis? फ्रीक्वेंसी एनालिसिस क्या होता है? Probability of occurrences of extreme events you are trying to correlate, or you are trying to calculate the probability of occurrence based on their magnitude of different events, है ना? So you have magnitudes of events. Now you are also assigning the probabilities of these magnitude with their probabilities. So that is called the frequency, or that is called the probability analysis. Frequency analysis का क्या मतलब होता है? अगर हम ये बात बोलें कि let's say a flood events which will occur 1 in 100 year, और 100 year flood return period जिसका है, उसका क्या मतलब होता है? 100 साल में एक बार. Is it possible that that flood will only come in 100 years? Is it possible that two events can be possible? और लेट्स से अगर हम 100 ईयर की बात करते हैं तो फर्स्ट 100 ईयर और नेक्स्ट 100 ईयर में क्या वो दोनों इवेंट्स पास पास हो सकते हैं? ऑफ कोर्स हो सकते हैं. सो इट इज़ अ काइंड ऑफ अ लाइकलीहुड सिनेरियो. कोई सर्टेनिटी नहीं है कि अगर मैंने बोला कि 100 ईयर फ्लड जो फ्रीक्वेंसी है या मैग्नीट्यूड है वो नेक्स्ट ईयर नहीं आएगा. इट इज़ अ all different magnitude events can be your 100 year flood frequencies. It depends based on your magnitude and their frequency levels like that. So when you are talking about let's say 50 year return periods, what is 50 year return periods? जो 50 साल में आता है. 10 year return periods जो 10 साल में एक बार आता है. 2 years return periods जो हर 2 साल में आता है. What is that event? That is called median behavior. What is median? What is median? What is mode? What is mean? Mean is the average value. Mode? Maximum occurrences. What is median? Exactly between. Exactly between. So हाँ, तो मीडियन वैल्यू का मतलब ये होता है, अगर तुमने प्रोबेबिलिटी डिस्ट्रीब्यूशन फंक्शन बनाया तो उसके सबसे मिडिल में जो वैल्यू आएगी दैट इज मीडियन वैल्यू। अगर उसमें एक लाइन तुमने खींचा और वो प्रोबेबिलिटी डिस्ट्रीब्यूशन फंक्शन को दो इक्वल पार्ट में डिवाइड कर दे, दैट इज कॉल्ड मीडियन वैल्यू। After arranging, yes, of course, when you are arranging the data set, you are moving from this end to that end, and then you are finding the middle point, right? That is how basically it is defined. So basically the frequency analysis is the method where you are trying to calculate the probability of occurrences of each different events with their corresponding magnitude. Once you establish this fact between frequency of occurrences with their magnitude, now the next step would be to calculate what is the magnitude of the flood events which will occur 1 in 100 year. अब इस इंफॉर्मेशन की यूजफुलनेस क्यों है, क्यों हम करते हैं इसको? Why it is required to calculate 100 year return period flood? क्या चीज़ करने के लिए हमें क्यों जरूरी है 100 ईयर फ्लड को कैलकुलेट करना या 100 ईयर ड्राउट इवेंट्स को कैलकुलेट करना? डिज़ाइन करने के लिए, रिजर्वायर डिज़ाइन करने के लिए, इंफ्रास्ट्रक्चर डिज़ाइन करने के लिए, या उस अगर 100 ईयर फ्लड इवेंट्स आता है या 100 ईयर एक्सट्रीम रेनफॉल इवेंट्स आता है तो उस हिसाब से हमें स्टॉर्म वाटर ड्रेनेज सिस्टम बनाने के लिए, ताकि वो इवेंट आएगा तो सारा का सारा पानी इवैक्यूएट हो जाएगा, लाइक दैट. So therefore this is the why this frequency analysis are is very important, and that is why we hydrologists use this kind of analysis for different purposes. So this is we have gone through already. We have also discussed about this graph. These things we have already discussed. Let's go straight to that example. Suppose we are measuring a river discharge for a one particular river basin for 45 years. ठीक है, since 1950 to 1994, let's say, that is total 45 years of the data set. Now for each year you are calculating the maximum value. अब maximum value calculate करने के क्या तरीके होते हैं? We have talked in the previous lecture. There are two methods. One is block maxima, second is POT, peak over threshold. Block maxima मतलब, let's say in this case you are using 365 values. Out of 365 values you are calculating what is the maximum value. So for 1950, 804 is your maximum value. 1951, 1090 is your maximum value. ठीक है, 1952, 1580, and similarly 1994, 348. This is the maximum value. इससे मैक्सिमम वैल्यू गई नहीं उस साल. दिस इज द टॉप वैल्यू फॉर दैट पर्टिकुलर ईयर. नाउ यू हैव ऑलरेडी कैलकुलेटेड दीज वैल्यूज, यू हैव टेबुलेटेड देम अकॉर्डिंग टू दैट डिफरेंट ईयर नंबर. So now this is, you can also plot, this will similar to this curve you will appear, and you can also draw a line. Let's say हमने 1500 पे एक लाइन और 1500 के आसपास एक लाइन ड्रॉ कर दी और उसके ऊपर बोला कि हाउ मेनी इवेंट्स आर देयर दैट इज कैन बी कंसिडर्ड एज एक्सट्रीम फ्लडिंग इवेंट्स. नाउ यू कैन आइडेंटिफाई हियर इफ यू हैव जस्ट मेंशन 1500 क्यूमेक्स इज अ थ्रेशोल्ड where it is classified as a extreme flooding conditions. In that case 1952 can be your one of the year which is extreme flooding event happened in 1952, 1956, 57, 58, 72, 76 and 81 and 87 and 92. These are the years where a flood events were crossing above 1500. अब कुछ लोग पूछेंगे ये 1500 को कैसे हमने कर लिया इसको एक्सट्रीम इवेंट्स. इट माइट पॉसिबल दैट रिवर जो क्रॉस सेक्शन होगा वो 1500 को एक डेंजर लेवल बताता होगा, है ना. हो सकता है कि अगर हमने इस जो ये एनालिसिस की है, लेट्स से यू आर यूजिंग दिस एनालिसिस फॉर वेरी माइनर ट्रिब्यूटरी इन नर्मदा वेयर द फ्लड विल मैग्नीट्यूड विल बी नॉट दैट मच हाई, बट लेट्स से इफ यू आर यूजिंग दिस एनालिसिस फॉर मेन चैनल ऑफ द नर्मदा, ऑफ कोर्स द फ्लड विल बी वेरी हाई magnitude. There the threshold will be very high because bankfull condition will be higher values, right? So similarly, based on that we have identified this threshold, and based on this threshold we are trying to find out which year your values were greater than 1500 qmax or certain extreme value thresholds like that. Now you have already quantified, marked those year where you have observed. Now in this way you can calculate what is the difference between one event to the another event. वन इवेंट टू द अनदर इवेंट का मतलब लेट्स से एक इवेंट हुआ है 1952 को, अब इसके बाद दूसरा इवेंट कब हुआ है 56 में, तो इसके दोनों के डिफरेंस कितने हैं 4 इयर्स है ना. 1952 को अगर हम छोड़ दें 53, 54, 55, 56 दैट इज अ 4 इयर्स राइट. देन देयर इज अनदर रिकरेंस इंटरवल इज 57 1, 58 1. देन देयर इज द नेक्स्ट इवेंट occurred in 1972, which means the total duration is 14. Then the another event appeared in 1976, which means the recurrence interval from 1972 to 76 is 4 years. Then 81, 87 and 92 we have calculated the recurrence interval of these different flood events, and based on that we would be able to calculate what is the average recurrence interval. We can calculate right, इसको हम जोड़ लेते हैं and divided by how many times it reoccurred 8 times. We divide by 8 and that will tell you about 5 years. So basically on an average the flood of 1500 crossing magnitude will occur 5 years in average manner. But we have in the data set we have already seen there are instances when 14 years long record these flood events were not appeared, but there are instances when consecutive years, for example here you look at 57, 58, 56 consecutive years these events occurred, and there are events where we have 14 years gap like that. So which means this values is just for your interpretation purposes for average reoccurrence of floods for one particular period. 5 years means these events can occur in 5 years on average durations, but it might also possible that consecutive events can be crossing above that particular thresholds as well. So this is basically sort of a written period of that particular thresholds which we can calculate from the data set. Now you have the Excel data, ठीक है. अब Excel data पे हम एक threshold बना सकते हैं. We can do similar analysis and we can calculate what is the recurrence period of any given threshold. We can change the threshold and we can get the different reoccurrence periods, है ना. And based on that we can make a plot between the reoccurrence period and your threshold values. That will tell you about what is the relationship between the magnitude and their return periods. That is sort of the relationship we can get from the data. Now basically we have got the probability of occurrences of these particular events is 5 years, right. What is the return period formula? जो T होता है ना, return period और probability is inversely proportional to each other. T is equal to 1 by P, P is equal to 1 by T. Okay. So let's say if you know the time period, which is we know that from the data set itself, that is 5 years. Now somebody will tell you about, now can you calculate the probability of occurrence of magnitude which are crossing above 1500 qmax? The answer is yes, because we know that time period T, we can divide 1 by T, 1 by 5 and you can calculate probabilities which is equal to 0.2. ठीक है, 20% चांस है कि जो मैग्नीट्यूड है that will cross above 1500 qmax like that. Now there is another way of ranking the data set and calculating the magnitude probability of each different event. So जो previous example हमने देखा, इसमें एक problem है. There is one problem is we are not calculating the probability of occurrences of each different events magnitudes. We are only focusing on the threshold, whether it is 1500, 2000, 2500 like that. But somebody can also ask you, right, what is the probability of occurrence of 804? Na? तब तो हमें 800 के ऊपर हमें लगाना पड़ेगा थ्रेशोल्ड, देन वी कैन कैलकुलेट इट. So then there is a multiple times we have to apply this whole theory one again and again, then we have to calculate. Is there any other way to calculate the probability of occurrence of individual flood events, and then we can relate with your frequencies with the magnitude, and then we can find out, let's say 100 years or 50 years or more than that return periods like that. Yes, there is a way we can do that. So there is a probability plotting formula we can use. ये होता है P is equal to the cumulative probability is equal to small m divided by n plus 1. Small m का मतलब होता है rank, ranking. When we are using descending data set, घटते हुए क्रम में, okay. So the most highest value we will give them a 1 rank, and second highest is 2, third highest is 3, like that. And that is you called the rank m. N is called the total number of values with your data set. How many value data points you have in your data points data set, right? So that is n, and then we add n plus 1 here, and you will get some sort of probability number. n plus 1 क्यों कर रहे हैं यहाँ पे? इसका एक reason है. So for example, it might possible that there are very low number and you will get very low probability as well. That is why we are adding here one number here. So for example, this is the case here, the data set you have. In this data set you have the annual maximum value, okay. Now you can arrange this data set. What is the maximum value here? So अगर हम इस डेटा को दोबारा से देखेंगे ना, this is the same data set which I am showing there. So 804, this is the data, okay. What is the maximum value is 3069 maximum value. So this is your maximum value. I think second maximum is somewhere 1982. Yes. So this is the second maximum. So similarly we can calculate third, fourth, fifth, like that, and we can arrange our data set like that, okay. So 3069, 18982, 1657, 1651, 42. Similarly we can arrange the data set from the highest to the lowest one, and then we can rank this data set, okay. That is ranking is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So I have only written only 10 or 11 numbers. We will repeat this exercise with Excel. Whatever the data set I have shared with you, you can open the data, you can do this analysis here only, and then we will make a plot between the probability of occurrences with the magnitude, and then we can correlate with each other. So here basically we can calculate the rank, assign the rank, and the same formula, this one, m by n plus 1. Here you can calculate the probability of occurrences. P is equal to m by n plus 1. So for this, m is 1, n is total number of data points. How many data points we have? I think 45, yes. So basically here this is 1 by 45 plus 1, that is 1 by 46, and that is your probability of occurrences. P is equal to 1 by 46, and you will get the probability of occurrences is equal to 0.02 and something like that, okay. And then if you reverse this probability 1 by P, that will give you the time period, that return period 46. Similarly, you can calculate this probability of occurrences for all these different discharge magnitude, and correspondingly you will also get the return period for that probability values, okay. What is the advantage here? Now you can clearly say that what is the probability of occurrences for 1254 values, 1642 values, 16. So individually whatever values you have with your data set, now you know about the probabilities and corresponding your return periods, okay. So now using this data you can make some sort of a plot. This is scatter plot, right? Scatter plot between return period and the Q max. Return period क्या है यहाँ पे? Which we have calculated t value, and what is your Q max value? that is your magnitude. Magnitude is what? These are the magnitudes like that. So you have already arranged it, and correspondingly you have the t value, and based on this t value you can basically plot the data points, okay, the maximum value and return period, and then you can basically calculate what is the value for, let's say, you have got the equation here, y is equal to 712.44 natural log x plus something values. Here you can put the x value. What is x value? X value is your return period, x axis value, okay. You put x axis value here in this particular equation, and you will able to get the return period for y values, and you will get the y values value, and that is basically corresponding to your return period. So you can put 100 year here, 100 value here, that is your 100-year return period flood magnitude, and you will get the y value, that is you will tell you about what is the 100-year return period flood magnitude, है ना, that you will be able to get from that particular equations. So this is basically sort of empirical way of dealing the data set, empirical way of dealing the calculating the frequencies from the flood data set. Of course, this is a very simplistic method, therefore it might also create some sort of errors as well when you are projecting for 100 years or 50 years flood frequencies. Therefore, we can use the extreme value theory type 1 or type 2 or type 3 for minimizing that uncertainty in your projections, okay. So we will first we will see this particular example through the Excel first, and then we will discuss about the later part of this presentation with some more example. So I hope you got all the this data set. So I have already done this exercise, maybe you can delete these columns and we can do this again, okay. So you can jump to the sheet 4 where we have written these values. So this is sheet 4. We will work on sheet 4, even though I have already that is basically in sheet 1, sheet 2, sheet 3 we have done this analysis. So basically first of all we will remove this text thing, okay, because we do not need that. We know that year and Qmax. So basically this is your data points, Qmax, and we have to do some sort of ranking. So basically we can arrange this data from highest to lowest order. How do we do that? Okay, so this is how we can do that. Sort and filter, there is a one command here. If you open this command, there is a Z to A. Z matlab highest one, A matlab lowest one. When you click this particular command, here basically you will be able to organize this data set from the highest to lowest order. Now you can rank this data. So you simply put here 1, then 2, then 3, and then maybe you have to basically assign all the ranks for your whole column. So that is basically you can assign the rank of the data, that is 1, 2, 3, 4, 5, 6, 7, 8 till your 45. क्या चीज़? अगर किसी ईयर में सेम आ जाए तो दैट्स अ गुड क्वेश्चन एक्चुअली. So maybe we can assign the same rank, right? Assign with same rank. हमें उसको सेम रैंक असाइन करना पड़ेगा ना, तो पीछे वाले का चेंज हो जाएगा, उसको हमें मैनुअली करेक्ट करना पड़ेगा. Is there any similar values? Yes, here. So maybe we can put here 15 also. Okay. There is one more here. So 29, this is 30, and here also. So there are 3 instances where we have similar values. You corrected this? Done? Okay, so once you have already corrected this rank, now you can calculate the probabilities. How do we do that? We can add equal to there, then we can write the formula. So we can, what is the rank? Rank is 1 divided by how many numbers are there? Total numbers 45. So that is 45 plus 1, m divided by n plus 1, right? If you click enter, that you will get the probability of the first event, and if you just you will get the probability of all the events. M is equal to, sorry, P is equal to m n plus 1. So m is your basically rank, n is your total number of data points. In our case it is 45. Are you able to calculate the probabilities? Done? Now you have probabilities. Now you can also calculate the return period. How do we do that? Is equal to 1 by this value d1, and if you click enter, you will get some value 46, and then you just stretch this whole column and you will get the value for all the values for that return period. Now you know the probability of occurrences of each extreme events and corresponding written period. Okay. Now you can calculate, you can make a graph which are correlating each other, that is your written period plus your magnitude, so that you will be able to show the relationship between written period and the magnitude. So insert, you can go to the insert data here, not like this. So this is a blank graph. Here you can go to select data and here add data. What is the x value? X value of your written period plot. X value क्या होती है written period plot की? जो written period plot हमने डिस्कस किया था, number of years, written periods ना, written periods हमने क्या कैलकुलेट किया? So basically written periods are this one. Yes, this axis, last column, and then you are calculating the magnitude, which is your y axis. Y axis is your B column. Okay. Now maybe you can also do some sort of logarithmic transformation here, because generally you see that format axis, probability here logarithmic. Now you can see this curve is now more like a linear graph here. Once you have converted your curve into a logarithmic scale. So are you able to do that analysis? Is there any problem? Is there any problem? कोई समस्या है? हाँ, क्या समस्या है? गिर न जाए बस. 45 है तो कैलकुलेट करो. हो गया? प्रोबेबिलिटी आ गई. यू गॉट द प्रोबेबिलिटी. रिटर्न पीरियड आ गया 1/p. नाउ यू कैन मेक द ग्राफ लाइक दैट. सो इन x एक्सिस यू कैन इसको मैं इसे year, this is logarithmic, this is R, display equation. So that is equation we got, y is equal to 729.3. This is ln x plus 31.297. So this is the equation we got. Now the question is, if I put x is equal to 50, what is the value of 50-year return period flood? Magnitude, y value. Can you calculate using the Excel? 2 to the power 2 to the power 4? No. So if you look at this graph here, 10 and 100 here, so you make this is 20, this is 30, this is 40, 50, somewhere here 50, right? Might be 2000. Okay, any other? But is it possible that कि 46 ईयर का जो रिटर्न पीरियड है उसकी वैल्यू है 3669 and 50 years is little lesser than that? It should be greater than, right? You can recheck your calculation again, क्योंकि रिटर्न पीरियड के हिसाब से तो बढ़ना चाहिए फ्लड, है ना? तो 50 years का जो है कैसे करेंगे कैलकुलेट, एक्सेल में कैसे करेंगे कैलकुलेट? तो बेसिकली हमें क्या करना है, हमें एक कोई सेल पे क्लिक कर देना है, ठीक है, और वहाँ पर इक्वल टू लगा देना है सबसे पहले, ठीक है. वंस यू एडेड द इक्वल टू इट विल बिकम ए फॉर्मूला. नाउ यू राइट द फॉर्मूला 729.31 multiplied by ln. ln is a function here. You click the ln this function, है ना, and now you write here the number. ln के अंदर क्या है, x. What value we are going supposed to add here in x? 50. 50 plus ये क्या आ गया, 50 plus 31.297. Okay, that is exactly correct. You are 2884.37. Yeah. Why it is like this? Now again there is another question. ऐसा क्यों है, ऐसा क्यों हुआ कि 46 ईयर की जो वैल्यू है it was higher, but when we yeah, so basically if you look at this particular line here, you can see here these values are little higher compared to your original value. So if you extrapolate this value, it will somewhere here, it is just touching your 3000, and therefore your values are little lesser than whatever you have already observed in the data. So there are some sort of errors or present in your the model data with your actual values, and that is your uncertainty. Might be 5-10% uncertainty in your return period estimate. Can you calculate 100-year return period flood? 100-year return period flood. अब x की जगह पे हमें 50 की जगह 100 रखना है. ओके, हाउ मच? 33 894. This was your 100-year return period flood. Can we cross check this? we can add here 100. Okay, so this is the value we got. So what I just demonstrated that suppose you have the extreme flow data set like this. Okay, you can actually calculate the probability. Once you have already calculated the probability P is equal to m by n plus 1, this relationship, you can calculate the return period T, which is T is equal to 1 by P. Okay, you can calculate the return period, then you can do some sort of relationship between your return period with your descending Qmax values, and you can make some sort of scatter plot between return period x axis, and in the y axis you will plot these the flood magnitudes. Yes, and that you will get some sort of log transformed scale, this chart, and you will get some sort of relations between y is the function of x. Function of x is what? X is your return period, y is your magnitude. Now you put x value, you will get y value. X की value हमने 50 रखी, so that will tell you about the 50-year return period flood. If you put 100-year return period, it will give you the 100-year return period flood magnitude. You can also extend this analysis, 500 का भी कर सकते हैं, but sometimes extrapolating these values up to 3-4 times, it's not accurate, because as we move forward from the data points, the uncertainty will also expand. तो हमें पता नहीं है कि अगर हमने 500 का निकाला है तो उसमें कितने % अनसर्टेनिटी हो सकती है 100% अनसर्टेनिटी हो, है ना. तो बेसिकली दिस इज व्हाट बेसिकली वी कैन डू दिस सॉर्ट ऑफ एनालिसिस टू कैलकुलेट द रिटर्न पीरियड फ्लड मैग्नीट्यूड. अब क्वेश्चन ये होता है कि ये जो हमने अभी काम किया है, इज इट ओनली एप्लीकेबल टू फ्लड्स और सम अदर डेटा सेट्स एज वेल? वी कैन डू अदर डेटा सेट एज वेल. रेनफॉल एक्सट्रीम के लिए भी कर सकते हैं, टेम्परेचर एक्सट्रीम के लिए भी कर सकते हैं, और इसी के साथ साथ हम जो है अदर पैरामीटर्स जो भी हैं उन पे भी हम काम कर सकते हैं. ठीक है, it is clear to everyone now. If you can have another set of data set, you can use your data set and you can calculate the 100-year and 50-year return period floods and calculate the magnitude. Okay, this is very easy. It's not a rocket science, very easy tool. ठीक है, if you have any questions you can still ask. You can also think about making some sort of function. Function कहाँ पे? You can think about making this kind of calculation in MATLAB as a function. Okay, if you make a function, you just have to input value and that function will tell you about the probability magnitude. Now suppose let's say you have a region where you have 51 stations. ठीक है, 51 stations हैं हमारे पास, and for the 51 stations you have all these kind of the data, extreme value, extreme flow data. ठीक है, now for the 51 stations you can do similar analysis. For each different stations you will get different relationship. y और x का जो relationship होगा वो different होगा. क्यों different होगा? हाँ, Qmax सब बराबर रहेगा, रिलेशन डिफरेंट रहेगा. सो फॉर एग्जांपल लेट्स से अगर हम ये जो फंक्शनल रिलेशनशिप हमने डेवलप किया, ये नर्मदा को अगर हम एग्जांपल मान लेते हैं, यू जस्ट इमेजिन नर्मदा बेसिन. ठीक है, नर्मदा में कुछ अपस्ट्रीम एरिया होगा और कुछ डाउनस्ट्रीम वाला जो वहाँ पर हम मेजरमेंट कर रहे होंगे स्टेशंस. तो जो अपस्ट्रीम वाला जो स्टेशंस वाला एरिया होगा, ऑफ कोर्स वहाँ पे डिस्चार्ज की वैल्यू हाई होगी, लो होगी, कम होगी. तो अगर कम होगी तो वहाँ पर जो एक्सट्रीम वैल्यू आने की जो वैल्यूज़ हैं वो भी रिलेटिवली कम होंगी. मेरा कहने का मतलब ये है कि अगर हम नर्मदा में गरुड़ेश्वर या और भी नीचे वाले जो रीजन है उसमें अगर हमने मेजरमेंट किया तो ऑफ कोर्स वहाँ पे वैल्यू आएगी 2000, 3000, 5000 क्यूमैक्स, ठीक है। जो नर्मदा का जो अपस्ट्रीम वाला रीजन है वहाँ पर आपकी वैल्यू आएगी 250, 500, 1000 कुड बी द एक्सट्रीम कंडीशन, ठीक है। तो उस कंडीशन में क्योंकि एक्सट्रीम वैल्यूज भी आपकी डिफरेंट बदल रही हैं and correspondingly because of your climate change or climate conditions, hydrological conditions, geographical locations and topography whatever, and also the location wise upstream and downstream conditions, so your functional relationship will also be different. So which means it is possible that in the upstream region your functional relationship is equal to y is equal to f1x, ठीक है, फंक्शन बदल जाएगा। एंड दूसरा जो तुम्हारा लेट्स से इफ यू इन द डाउनस्ट्रीम साइड योर फंक्शनल रिलेशनशिप विल बी एफ वाई इज इक्वल टू f2x। अब इन दोनों फंक्शनल रिलेशनशिप को जब हम बना देंगे, कैन वी कमेंट ऑन दैट कि व्हाट इज द फ्लड पोटेंशियल ऑन दीज डिफरेंट पॉइंट्स? मेरा सवाल समझो। तो दिस इज अ पार्ट ऑफ यू कैन थिंक अबाउट योर डेटा सेट, विथ योर डेटा यू कैन ऑल्सो प्ले विथ इट। Suppose there are two river basins which are exactly similar in size, aerial wise similar, climatic conditions different है, lithological conditions different है, hydrological conditions भी different होंगी, ठीक है। एरिया सेम है और हम उसको कंसीडर कर सकते हैं आपस में कंपेयर करने के लिए, ठीक है, ओके। सो फॉर एग्जांपल लेट्स से इन वन स्टेशन यू गॉट y इज इक्वल टू f1x, and another station you will get y is equal to f2x. So this is, let's say, station number 1, this is station number 2, okay. Can you comment on both the stations property, which station has the higher potential to generate flood? इसका एप्लीकेशन क्या हो सकता है? इसका एप्लीकेशन ये हो सकता है कि हम ये बता सकते हैं कि ये जो स्टेशन है ना ये फ्लड प्रोन है कंपेयर टू दैट स्टेशंस, रिलेटिवली मोर फ्लड प्रोन दैट वन। हाउ डू वी डू दैट? ये ना वायर इतना छोटा है, आई कैन नॉट गो देयर। हाँ, so basically what we can do, I just give you some clue maybe, and then you can start thinking about the whole thing with your data points. So let's say this is your x and y plot, what we have done in the Excel. So this is your x value, this is your y value, this is your log transformed x value, and the relationship we got something like this, right? A linear scale, a logarithmic a plot, but because we are plotting in the logarithmic scale itself, that is looks like a linear plot. So it might possible that you will get this plot for S1, ठीक है, and you might get another plot for S2 because hydrological conditions are different, area wise same. Both the river basin can generate similar level of the discharge because area is same, but because of the climatic conditions, lithological condition, everything is different. Therefore, these two things are different in flood potential. Now you can look at, let's say here somewhere is 10. Now you can draw a line here. Now you see that there is a one point here, another point here. So let's say this is your A, this is your B. So A is greater than B, which means at 10-year return period S1 पे जो magnitude है that is greater than your 10-year return period of magnitude of your S2 station, which means the frequent events 10 years मतलब considerably we can consider as a frequent events, 10 years में आते हैं, ठीक है। In 10 years frequent events, the S1 produce more vulnerable flood conditions compared to S2. Similarly, if you go to some other, let's say this is 100 here, and you make a line here, that will also give you that this is, let's say, C and this is D, C is greater than your D. It means S1 is always greater than S2. But there are some conditions which can also be possible. There are some conditions which are also be possible. For example, so this is X, this is Y. Let's say this is S2, this is S1. In this case, it is also possible. In this case, let's say this is 1 here, this is let's say 10 here, and this is, let's say, 100 here. In this case, that is A and B, and this is not A, this is A is this, B is this, and this is C and D. So in this case, A is less than B and C is greater than D. A is less than B मतलब जो frequent event है S1 पे, that is actually lower than S2, which means in terms of frequent event, S2 has more magnitude compared to S1, right? But when we are talking about extreme events which are occurring very rarely, in that conditions we observe that S1 has more magnitude than S2. That is also possible. So this way we can do some sort of complex interaction between station wise, and we can think about what is the governing mechanism behind all these different processes. That can be also be done. So with this simple example, let's say you have multiple stations data in a river basin. We can do this kind of analysis, and then we can think about which station has more flood prone compared to the frequent event or moderately frequent event or rare events like that. You can just mark them, or maybe you can make some sort of spatial plot and highlight them like that, or maybe you can also calculate what is the percentage difference between magnitude wise, which station has more magnitude or like that. So this kind of the analysis you can do, and you can show based on that analysis. So that is what I wanted to add here, because we have done a very simple exercise. Now you can extend this analysis for more complex one. For let's say you take whole peninsular region. सारा peninsular region का मतलब जैसे कि कावेरी है, कृष्णा है, गोदावरी है. So lots of rivers there, and you can club it together, and you can think about making which river basin is more flood prone compared to the other. That can be done, right? अच्छा, इसमें एक और बात है यहाँ पर. There is one another thing is, sometimes this kind of analysis is very useful when you do some sort of normalization. क्योंकि कभी कभी हमें ऐसा होता है कि हम स्टेशंस को आपस में कंपेयर नहीं कर सकते. What is the reason behind it? Let's say there is a station in Narmada which is located upstream, है ना, and the area of that particular upstream region is very low, and there is a station in the downstream part where area is very high. तो of course जहाँ पर एरिया बहुत ज़्यादा होता है वहाँ पर फ्लड का मैग्नीट्यूड भी बहुत ज़्यादा होता है. एरिया इज़ डायरेक्टली प्रोपोर्शनल टू योर फ्लड मैग्नीट्यूड्स. ठीक है. So in that case maybe you can think about normalizing your flood values with your area. एरिया नॉर्मलाइजेशन. एरिया नॉर्मलाइजेशन करके भी हम जो है बहुत सारे स्टेशंस को आपस में कंपेयर कर सकते हैं, और कंपेयर करने के बाद उनके जो हिडन पैटर्न है उसको हम आइडेंटिफाई करके बता सकते हैं कि अगर नर्मदा में लेट से फ्लड आ रही है तो कौन सा रीजन एक्चुअल में रिस्पॉन्सिबल है, और लेट से कावेरी में, कृष्णा में, गोदावरी में अगर फ्लड आ रही है या बढ़ गई है, लेट से यू कैन ब्रेक दिस एनालिसिस फॉर मल्टी टेम्पोरल टाइम. You can break this analysis for 50 years and 50 years, and then you can compare कि जो पहला 50 year है उसमें कितना मैग्नीट्यूड आता था और जो नेक्स्ट वाला 50 years है उसमें कितना मैग्नीट्यूड आता है. Of course there will be a difference between these things also. So there are spatial analysis you can also do, and multi-temporal analysis you can also do, and you can compare your results with your ground availability or whatever the ground reporting is there. You can compare and you can just do very interesting work on this. So that is what we have already we have also done sort of multiple work based on this analysis. Not exactly this thing. This is a very simple one, but we have done some sort of gumball जो हमने पढ़ाया ना सुबह में एक्सट्रीम वैल्यू डिस्ट्रीब्यूशन फंक्शन गम्बल फ्री चिट और जो वीबल वगैरह है उसको हमने फिट करके we have done some sort of analysis in upper Ganga basin. If you go to my profile, that paper is already published in 2021 in scientific reports. So we have compared the different stations in upper Ganga basin, and we compared which of the stations are more prone to flood. And then we have also done some sort of flow duration curve analysis and sediment analysis like that to understand the overall hydrological behavior of the upper Ganga basin, and we can compare with the neighboring. For example, upper Ganga is found by two river basins, Bhagirathi and Alaknanda, and Bhagirathi and Alaknanda we compared together which area is more flood prone. So I hope you got some research insights from this simple exercise as well. If you have any questions, you can ask. No questions? Whatever. Sink? Steam flow. This discharge data. So there is two options. In India there are two classification. One is the Ganga, Indus and all these river system which are classified, because these rivers are coming from different countries and flow to the different countries as well, है ना. तो होता क्या है कि the CWC is considering those rivers as a classified river basins. There are few rivers which are not classified. For example, peninsular basins which are originating from India, and they are going. These rivers are actually meeting with the ocean. So that is a classified. So those rivers basins which are classified or no not classified can be accessed by India WARIS portal. India WRIS portal. Okay. There you will get the discharge data. So there they have uploaded there, and you can download multiple stations data from there only. On the daily basis, yeah. अब ये जो है अलग अलग स्टेशंस के लिए अलग अलग है. फॉर एग्जांपल there are many stations which are functional after 1990, so probably you will not be able to get the data before 90. There are many stations which are operational since 1960s, so you will get the data from 1960. 30-40 is normal, you will get the data daily basis. So you will get the daily basis data, you can apply this whole algorithm or complex one, and then you can calculate the return period analysis for different reasons like that. And there is another way, you can directly request the data to the CWC. The Aditya Sarma ji aaye the aaj, so they have all the data set controlled with them. So basically for the classified river basin you can make a request, and they will also release the data with some terms and condition. अब मिलता नहीं है वो बात की अलग बात है. It will take time, but yes, they give the data set. Classified के साथ बस ये terms है कि you cannot share the data with anyone. If you have ordered the data, you have to keep your data within yourself. That is the one. Any other points you want to add, or you have any suggestions so that I can improve? No, everything whatever taught, you got the points. Bullseye. Very good. Okay. Okay, thank you so much for listening to me. Huh?